Yes. Good morning, students. Today we are going to discuss there is projectile motion. See projectiles. See there are oblique projectiles, horizontal projectiles. Projectile, a body, we are projected with certain angle with the horizontal line. See with the horizontal line, if a body is projected at certain angle other than 90 degrees, if body is inclined, okay, so with some inclination with the horizontal line, if a body is projected, we'll call it as a projectiles. Oblique projectile, we are having oblique projectile, horizontal projectile, etc. On the surface of inclined surface also you can project a body. See in the projectile motion, basically, see oblique projectile, object is launched in the air at an angle. See directly vertical or horizontal, when object is launched with an angle is called projectile. The trajectory of a projectile is called, see it is the trajectory means the path travelled by a body in the projectile. What we will call it is a slope. It is usually parabola. Parabola is the path travelled here. So that is trajectory. What the path travelled by a projectile, we will call it as a trajectory. The trajectory of a projectile, oblique projectile, is parabola. So projectile motion. See in the projectile motion, basically we have to consider in the equations of kinematics how we are consider v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as, sn is equal to u plus a into n minus half. See these are the normally what we take. See the projectiles. See the projectile, there are two different will be there. See one is horizontal motion along x-axis and along y-axis. There are two different equations we are going to consider here. See Vx is equal to ux plus ax into t. This is along horizontal direction. Similarly, the equation Vy equal to uy plus ay into t. This is in vertical. The equations are here. There are two different equations, two sets of equations will be there. V is equal to u plus at. One is along horizontal, Vx is equal to ux plus ax into t. Along vertical, Vy is equal to uy plus ay into t. So these are the two types of equations. One is along horizontal and along vertical. In the motion of the projectile, see the body, see whatever the projectile broken down into two separations, horizontal motion and vertical motion. See the horizontal motion is of the object is constant determined by the initial velocity. Horizontal motion we are to consider ux is equal to here u. In vertical we are considering uy. Okay, so initial velocity along vertical. Similarly, acceleration along x-axis, ax, the ax acceleration along x-axis will be 0 in the case of oblique projectiles. Ay we will should be considered as minus g. That is okay. So acceleration due to gravity in the acceleration. So like that, there are different quantities, vertical motion and as well as horizontal motion we have to consider, and there are two sets of equations will be there. For horizontal one set of equation, for vertical another set of equation. So we have to, by considering the two different sets, we have to decide, okay, so body have certain acceleration or certain velocity, certain distance or displacement, etc. In the projectile motion, this is the big change will be there. So that we have to consider. See, coming to the coming to this, the slide, oblique projectile. The motion of an oblique projectile can be broken into two separations. See, the oblique projectile is having certain angle. See, applications of projectile, where we where we are observing this projectile. See, recently there is a Ukraine-Russia war. See, daily we are listening the news, like watching news. There is intercontinental ballistic missiles, some all bombers, etc. These are all executes only projectile motion. They kick off at one point and they hit the target. Okay, with certain path. So basically, the applications of projectile, many applications in the different fields, like so. Basically, in wars and soccer, see, there is a football player or something like a golf. So they want to hit the target. They have to maintain this specific direction as well as horizontal and vertical. All should be considered. Then only you can reach the targets. These are the different applications. So this is missile. Okay, see something like body. See here there is a missile which is going to hit recently most of the since last 1 year Russia war. So Ukraine is facing so different explosions, like different missiles. See, they are coming from the land of Russia and hitting the target on the Ukraine. These are possible only through the projectiles only. See the trajectory. See, the trajectory is a parabola. Here, if you observe carefully, here the body is projected with initial velocity u. See, ux is horizontal component and uy is the vertical component. Ux is equal to u cos theta, uy is equal to u sin theta. At different places, okay, so ux, u cos theta, but at vertical maximum height, uy will be 0. Okay, so the maximum height, final initial velocity will be 0, but horizontal velocity will be there. Ux is equal to u cos theta, ux is equal to u cos theta, uy is equal to minus u sin theta when it is reaching the ground. See, these are the directions and everything. Maximum height. See, this maximum height and this will be the range, horizontal range from initial point to from here to here. So from initial to final, that we will call it as a range. Some important definitions we observe here. The important definitions like, so see, this is called a range. See, range from here to here. And this one is called the maximum height. See, the maximum height. Range is the horizontal distance. Maximum horizontal distance is called range. And maximum height is nothing but the height the body projected. So final velocity will be 0 there. Okay, uy will be 0. That is called maximum height. So the range formula. What is the range formula? See, the range formula, u square sine 2 theta by g. U square sine 2 theta by g. This is the formula for the range. And the maximum height formula. See, u square sine square theta by 2g. U square sine square theta by 2g. See, this is the formulas. And the next one is time of flight. The time of flight formula, 2u sin theta by g. 2u sin theta by g. See, time of flight. These are the different formulas we use in the projectiles. See, coming to the next. See, in this slide only we can see the maximum, see, the equation, what it is going to be there, the equation of a trajectory of a projectile. See, here the ux is equal to u cos theta, but the horizontal distance, some distance x, okay, so x is equal to us into t. Acceleration along x direction should be taken as 0. In the case of oblique projectile, acceleration along x direction should be taken as 0. This we have to consider. See, we have to remember this acceleration along x direction is 0. That you have to remember carefully. So that's why s is equal to ut plus of t square. Ax term is 0. X is equal to ux into t. So t is equal to here. See, actually here what it is, t is equal to x by ux. Ux is nothing but u cos theta. X by u cos theta. This is the important equation. The time x t is equal to x by u cos theta. Similarly in vertical motion, okay, see y equal to uy into t, uy into t plus of ay into t square. So acceleration along y axis is minus g. That's why uy is nothing but u sin theta. U sin theta. T is nothing but x by u cos theta. T is equal to x by u cos theta plus half into ay is nothing but minus g into t square. So now simplify this. If you simplify this, see u get cancelled. That's why x tan theta y is equal to x tan theta minus, okay, so t value is x square by, so u square 2u square cos square theta, 2u square cos square theta. This is the equation. Y is equal to ax square plus bx. Y is equal to ax square plus bx plus c. This is the equation of a parabola. Equation of a parabola. That's why the trajectory of a projectile is parabola. The trajectory of a projectile is parabola. This equation represents y is equal to x tan theta minus, so x square by 2u square cos square theta. Here a value is tan theta and b value is, okay, so b value is nothing but 1 by 2u square cos square theta. 2u square cos square theta. So that is nothing but y is equal to ax minus bx square. Y is equal to ax minus bx square. See, this is the way normally, so the parabola is going to be proved. Coming to the see here, if you observe the equation, what I derived, just now we derived, x is equal to ux into t plus half ax into t square. Then putting the value ux is equal to u cos theta, acceleration ax is equal to 0. So x is equal to u cos theta into 2 plus half into 0 t square. That is t is equal to x by u cos theta. See, the motion along vertical direction, y is equal to uy into t plus half ay into t square. Uy is equal to u sin theta, ay equal to minus g. This is very important in the oblique projectile. In oblique projectile, these values, like, see, like the ax value, and as well as, see, this ax value is 0. It's a very, very important value. We have to remember. And similarly, ay value is minus g. And ux equal to u cos theta, uy is equal to u sin theta. Substitute values. So u sin theta into t. T value is nothing but x by u cos theta. Ay is minus g. This is also important value. We have to remember. See, if you substitute, see, y is equal to u sin theta t plus half into minus gt square. T value x by u cos theta. X. See, it means x tan theta minus g divided by 2u square cos square theta into x square. See, this is the equation what we called the trajectory of a projectile is parabola. The trajectory of a projectile is parabola. With this equation only we can conclude that. Okay, see, yes. So thank you very much. We'll continue in the next video, the projectiles, the oblique projectiles, and what are the applications of projectiles, and etc. Thank you.